Data. How do we know it's a data? There's a D on it. Yeah. Pull the Carlsman, see it. Characteristics. It's still just characteristics, isn't it? If you saw these different flip-flops like in a figure, identify what kind of flip-flop it is, you should be able to pick it out. SR, RS, got an R and an S on it. Toggle, there's a T on it. Data, there's a D on it. Even this one, JK, JK. Unless, and we'll talk later, if we have this set up to act as like these other three, that's going to be different. So data flip-flop. Now we have preset and clear we got to deal with. Their data input, and it can be just a random set of highs and lows, it doesn't matter. Clock pulse, or our pulse train for timing, because the purpose of data is to what? Yeah, to synchronize it. Notice the inputs. Whenever you see the triangle, what do we call it? Well, just the triangle itself. Just this means edge trigger. That just means edge trigger. Now when you add it to an input, positive edge, inverter, negative, positive. Okay, edge of the what? Clock signal. So either the up clock, positive edge, or the down clock, negative edge. There's other names too, right? Negative edge can be called negative edge, trailing edge, lagging edge, remember that stuff? And that's in your handout, in your notes. It's just positive edge of the signal, up clock, leading edge, same stuff. And I still have Q and not Q, my outputs. Preset and clear are special. They're special. First off, preset function is what? Logic 1. Store 1. Clear, what is it? 0. And if either one of those have an activating signal, we're going to override all other inputs. It doesn't matter which one we're talking about. As long as it's a preset cleared, their function is to do this and override all other inputs. Override. So, what did I tell you to do first? Last time we reviewed this stuff, as far as preset and clear goes. That's the first thing I do. Look at preset and clear. If either one of them has an activating signal, that's what's going on. It doesn't matter what the clock's doing. Doesn't matter what bit of data is next. Doesn't matter. That's what matters. So if I do something like this, refer back to what you should already have in your brain housing. Clear requires a what? You require logic high to activate its function. Preset requires a logic low to activate its function. How do we turn them off? Well, no, one or the other. How do we turn them off, or how do we keep them off? We put a non-activating signal. So preset is off, isn't it? Yes. Okay. Clear is off. So what's the deal? What did I say? Rhymes with business as usual? Business as usual. Business as usual. Data, clock, everything's being synchronized. Bam, bam, bam. No problem. So in a case like this, preset clear. All right, well, hey, data's coming in, clock is synchronizing the data. Good to go. On the next negative edge of the clock, the output is what? For this example. Yeah, I'm here to stay the same, 1, because I didn't tell you what's being stored in, but you could assume, if you want, you can assume this, you can assume that. So if preset and clear are inactive, the next negative edge of the signal, because you got to remember what? What's the flip-flop waiting for? What's this flip-flop waiting for? It's waiting for the positive edge. I need a ham sandwich. Positive edge of the signal. I said negative edge. So if it's waiting for the positive edge, and you're asked the negative edge, it's going to stay in the same state because it's waiting for this. Everybody remember that?
Yes, sir.
So the next positive edge, okay, because right now we got 1, 1, 0. The next bit of data is what? Okay, so the next positive edge, here's what's coming in, synchronize the data, and so on and so forth. It's continuous, continuous, until something like this happens. What's going on now? Clear equals 0. I have an activating signal, so now cease all operations. That's what's going on right now. Done. Override this. Why is it 0? Because that's Clear's function. It's not that 0, it's this one. Make sense?
Yes, sir.
Okay. JK. This one's personal. So we can make these 3 out of it. Now, all in all by itself, as long as these two, J and K inputs have complementary eggs, basically a standard JK. They're just going to alternate back and forth. Still have a clear, still have a preset function, still have the clock. Q and not Q. JK, just like that. The inputs complement, that's what it is. Because you have to identify these flip-flops, don't forget. Hey, this one. If you see this, it's a freaking JK. What happens if, here's a question, here's an example. Identify this flip-flop right now. Identify. Identify that flip-flop. Toggle. Did I ask you to tell me what the next bit of data was, or what is it waiting for? All I asked was, or stated was, identify the flip-flop. That's it. Answer is toggle, and how do you know? There's a 1 on a J and a 1 on the K. It's considered, yes, an illegal function or illegal operation. That should tell you right now, oh, it's acting as a toggle. Got it. So this is going to function just like this. The only difference is I'm using the clock as the toggle, as the T input, but now it's every negative edge of the signal. So it's still going to function the same way as this. Now it's negative edge or it's edge trigger. It's the only big difference. 1 on a J and the 1 on a K is a what? Toggle flip-flop. Let's see who remembers that and forgets it. How do I make an RS flip-flop out of this thing?
Say with J clock. Use preset clear as your SNR.
Okay. Everybody hear that? You have a card?
Barely, sir.
Okay, well, speak up a little bit.
We're not going to use the J, the clock, or the K input. We're going to use preset and clear as the SNR input, and then it'll be configured like an SR flip-flop.
Pretty good? Yeah, that's it. So now this will function like this. As I can use preset and clear, hello, same thing, same functionality. Preset, clear, set, reset, same thing. What about if I want to make this one do like this, and if we take an inverter, these will still complement, but there's the input right here. Data flip-flop, I still need preset and clear. Inverter, that's a big telltale giveaway. If you see an inverter tied to the J and K inputs, hey, it's acting as a data. Because what if you don't see this? I only do that to help you guys out, or what inputs or outputs mimic the other flip-flops. This is probably all you're going to see. So that should tell you, right, oh, it's data. So just because you see a flip-flop with a J and a K on it doesn't mean that's the flip-flop. You have to pay attention. If you see a 1 and a 1, it's a toggle. If you see the inverter, it's a data. If you happen to see S and an R, it's an RS. Is that too tough?
No, sir.
That's all I got to say about that.